Hello again, everyone. This is Mr. V. Hill. Today we're going to be talking about raising sums to powers, or as I like to call it, the distributive property revisited. So just to review a little bit, of course, according to the order of operations, because of the way that works, we have that multiplication distributes over addition. So here we have a sum inside the parentheses, b plus c, being multiplied by this factor of a. So this multiplying by a will be distributed to both this term b and this term c. So if we want to distribute or show that just with some little arrows, as I always like to do, looks like that the a gets sent into both terms, and we have a times b plus a times c. All right. Then also we have that exponents distribute over multiplication, or what's commonly called the product to a power rule. In which case we have this product in the parentheses, a times b. That product is being raised to the power of m, so we distribute this exponent to both of these factors. So they end up with a to the m times b to the m. Now, next thing, exponents do not distribute over addition. That's 2 levels down. Multiplication is on top of addition in that hierarchy, so multiplication distributes over addition. Exponents are on top of multiplication in the hierarchy, so exponents distribute over multiplication. However, addition is 2 steps down from exponents, and so this does not distribute. For instance, if we have the sum 3 plus 4 raised to the power of 2, 3 plus 4 is 7, 7 squared is 49. But if we thought about this as distributing this exponent into that sum, what we would end up with is 3 squared plus 4 squared, which is of course 9 plus 16, which is 25. And of course 49 is definitely not the same thing as 25. So easy example to see that most definitely exponents do not distribute over addition. So when we do have something like this and we want to simplify it, what are we going to do? Well, it's basically going to be going back to this, the distributive property. So, for example, if we have x plus 4 squared, we're going to rewrite this as a multiplication. So this is x plus 4 times another x plus 4. So now we have a sum in here, and then we really have one whole factor right here. So we have this multiplying by x plus 4 is going to be distributed to each of these terms, this x and this 4. Just to keep everything together, I'll put a whole box around this and say I'm going to distribute that entire factor of x plus 4 into these other parentheses over here. We could go back the other way. It totally does not matter. So what we have here is this factor of x plus 4 is going to be distributed to the x, but then we also have the factor of x plus 4 distributed to this 4. So really, this addition right here is the exact same as that addition right there. But now we still have parentheses in our expression, so we're not done yet. Here we have a sum, and it's being multiplied by this factor of x. So we can take this factor of x and distribute it back into this sum, giving us x times x plus 4 times x. So this addition is the same as this addition. Then we still have the rest of it, plus this addition is the same as this one. We still have this x plus 4 times the factor of 4. Still have some parentheses in here to work with, but so we can distribute this multiplying by 4 into this sum. So this factor of 4 is going to be distributed in here. So we have x times x plus 4x plus x times another 4, which would also be 4x, plus 4 times 4. So this addition right here is this one right here. Let's just put 4 on there to keep it straight. This one has 3. And then the one in the middle is still the one underlined in blue. Now we just do a little combining like factors here. X times x is x squared. 4x plus 4x, oh, those are like terms now. We can add those together. 4x plus 4x is 8x. Plus, finally, 4 times 4 is 16. And now this is completely simplified. So really, if we're going to raise this sum to the power of 2, all it really is a repeated application of the distributive property. 3 times, in fact. So, I'm going to leave you with a couple of practice problems here. Do those now, and we'll check them at the beginning of the next class. Thanks for watching.